Python peeps, it's Prof G, and here comes the sun. It's time to break out those shades because we're going to be working with the light sensor to detect light using CircuitPython. And while we normally code in the excellent PyCharm, after we write our code in PyCharm, we're going to download free Moo software because it includes a plotter, and we're going to use that to graph our sensor reading while the code runs. Now, it has been announced that development on Moo is to be halted, so if you've got a better solution for plotting, let me know. It wouldn't surprise me to one day see a plotter at code.circuitpython.org, but as of this lesson, no plotters available, and I don't have any insider info. Let's code! If you're new here, welcome. You might want to check out the playlist to see how we got here. Now, the light sensor on the CircuitPlayground Bluefruit and Express is super easy to use in CircuitPython. This is a standard low-cost light sensor. If you look at the CPB, it's located roughly where you see the silkscreen image of the eye on the board. A8 on this image here is the pin number. Now, there's no external pad named A8, but that's the internal number that's used. We'll never use that. But to use the sensor, we're going to import a new library, and that's analog I/O. And that's because the light sensor is considered an analog sensor. For now, you can think of the difference between analog and digital this way. Digital inputs have two states, 1 or 0. When we created our buttons, we used the digital I/O library, and that's because the button has two states. Either it's on, pressed, true, or off, not pressed, false. Now, our light sensor is an analog sensor. It can provide a continuous and more nuanced curve of input. In fact, the results of the sensor can be a number from 0, absence of light, to 65,535, which is the brightest possible light. Now, there are digital sensors that are capable of providing more nuanced inputs too, so I don't want to get into the weeds in that, but I think this is a good enough introduction to analog and digital at this point in your CircuitPython career. So since the light sensor is an analog sensor, we need to import analog I/O. And next we need to create an object from the analog in class that's found inside of the analog I/O library, and that's what this line here is doing. And we create the object by passing board.light into the analog I/O class. Now, board.light is the location of the sensor on our CircuitPlayground Bluefruit or Express, and the object created by this class could be called anything, but why don't we call it light_sensor? That's a good name since it's a light sensor. Then to get the amount of light that's read by the light sensor, we just read light_sensors.value property. So here's our entire code, and you'll notice here that I have the light_sensors.value property in double parens, one for the print function and one more inside of it. Now, I don't need the second set of parens to print the value, but later in this lesson we'll download a free program called Moo, which can run our code on our board and plot the results in real time. Now, in order to plot, we need the value to be in what's called a tuple. A Python tuple is a collection of one or more values between parentheses separated by commas. And you've seen tuples before. Colors are tuples with 3 values. Now, one weird quirk about tuples in Python, if there's only one value, you have to have a comma at the end of that single value. One more thing, I've added a time sleep of 0.2 of a second at the end of our while true loop, just to slow down the output of print statements. Otherwise, the sensor readings would happen so fast that it'd be tough to read the changes. So this code is super simple. Let's try it out in PyCharm. Let's plug in our CircuitPlayground boards, launch PyCharm, and make a little awesome. So here's the code as per the previous lesson. I'm just going to change the comment up here so it reads light sensor. And since we're writing such a small amount of code, I'm going to delete everything else in this program and work from scratch. So our import statement is going to be board, time, analog I/O, one word, all lowercase. Now, analog I/O is actually built into core CircuitPython, and it's available for the CircuitPlayground boards. So since we've imported CircuitPython stubs into our PyCharm project already, we don't need to import anything else, and there's no extra library that we need to add to our board's lib folder. Now, the first thing we do is set up our light sensor, and we're going to call that light_sensor. We'll set that equal to, inside of the analog I/O library, we'll say .analog in class, capital A, capital I, and we're going to pass in between the parentheses board.light. That's the location of the light sensor on our CircuitPlayground board. And PyCharm knows about this and can suggest this in code completion because we used the CircuitPython setBoard command in an earlier lesson to set our board to the CircuitPlayground Bluefruit. You might have set yours to CircuitPlayground Express if you're using that board. The Express also has a built-in light sensor, and light is spelled with all caps. Then we'll just add our while true loop. And inside that loop, we'll say print with 2 parentheses. I'll say light_sensor.value, and I'll end that with a comma and close it with 2 parentheses. That puts the light sensor value in a tuple, and that allows us to plot it out in the Moo plotter. I'll show you that in a bit after we get things running in PyCharm. Then I'll just slow this down by saying time.sleep, and why don't we pass in 0.2 or 1/5 of a second. Then let's open the terminal and make sure you've got TO running. And we'll save. And oh, look at those values. That's our light sensor reading. And these values are fairly large because I've got a bright light right above my CircuitPlayground. Now remember, the light sensor is right by this eye, so if I cover it up, we can see the values go down. If I take my hand off slowly, you can see the numbers go up. So this is how you can read whether or not you've got light. If you wanted a particular task to be performed, say when the sun got up or a light was turned on, you could put an if statement in here and just experiment with the minimum threshold you wanted in order to be recognized as having a decent amount of light to perform your task. Cool, so let's save this to our CircuitPython school folder as light-sensor.py, and we can close the extra tab, and I'm going to highlight and copy all of the code in code.py. And now let's quit out of PyCharm, and we'll download and install Moo so that we can paste this code into Moo, run it on our CircuitPlayground boards, and I'll show you how we can plot sensor results in real time. Now, to be clear, you absolutely don't need to plot sensor output. If you're happy with having the values print to the terminal via TO, then you can leave it at that, but plotting is sometimes useful to give a visual sense of what's happening with sensor output. But if you want to plot out values, let's open a browser and we'll download free Moo. So head to this very unusual URL, codewith.moo. You should see a button on screen that says download. Click that. Choose the operating system for your computer and click download. Yours is probably saving to your downloads folder. Mine is saving to the desktop. And if you want to learn more about Moo, you can explore the tabs at the top for more information about tutorials, how-tos. Again, I've used Moo for years, and I did not find it to be as useful or reliable as PyCharm. That's why we're not using it. But PyCharm doesn't have a plotter, and Moo does. So just double-click to install Moo as you would with any other software package. After the installation, you can highlight these two icons that are on the desktop and drag them into the trash. But you should see in your application folder, you've got the Moo editor. I'm going to drag a version of this into my dock so it's easy to launch. Now before launching Moo, make sure that you've got your board plugged in, then start it up. You might get a security alert that asks you if you want to open something that was downloaded over the internet. Yes, you do. Click open. And Moo might take a little while to start up. Now there's a chance that you might see a screen when you start up for the first time that asks you to select mode, and if it does, there should be a selection called CircuitPython. Click that and click OK. So Moo is probably loading up the last thing you saved to your CircuitPy board, but if not, you can paste over any code that you copied from PyCharm. If you do that, you'll see a red dot next to the code.py tab. That's the same as the blue dot that we see in the tab in PyCharm. It's just the unsaved changes indicator. Then you can click on the serial button, although unfortunately when I did that, I found that Moo was hanging. Again, one of the reasons I don't like to use Moo is I think it's less reliable. On the Mac, at least, if you have any software that hangs, you can shift over to the Finder, then pull down the Apple menu and select Force Quit. I can see the Moo editor is in red, so it's definitely hung. I'm going to click that, click Force Quit, and then I found if I unplugged and then plugged my board back in and then relaunched Moo, things seem to work. Now if I click on Serial, I can see this is the equivalent of what we would see in the terminal via TO in PyCharm. These are readings from the light sensor output. I can grab the top of this window and drag it up. Then I'm going to click on Plotter, and I can see the value sort of creeping across the screen. You can adjust these windows using the margins any way you'd like. And then feel free to move your hand over the sensor on your CircuitPlayground board, and you'll see how this changes the output to the plotter. So that's pretty cool. That's how the plotter works with Moo. And you can use this whenever you need to plot values. Just make sure you put them in a tuple first. So once again, we had more big learning. We learned about analog versus digital. We set up our first analog input device, the light sensor. We got the light sensor reading a value from 0 to 65,535, and we printed the value in a tuple for plotting in Moo. Hopefully you can put what you just learned about the light sensor to work as you make something awesome.